SQL is a very important skill if you want to build your career as a data professional or a software engineer, and I'm glad to announce that with this video we are beginning SQL tutorial series. So we'll cover all the basic concepts. We'll also have exercises as well. Now these videos are basically taken from my premium SQL course on Codebasics.io, which has received tremendous reviews so far. So I'm going to take all the free videos from that course and publish them as YouTube videos, and once again there will be an exercises. So let's begin with the installation of MySQL. Now we will install MySQL on Windows. The first thing I will do is type add remove program and remove any pre-existing installation of MySQL. So when I look at this, I find bunch of MySQL components which are installed on my machine. So I will uninstall them one by one. If you don't see any of these components, then don't worry. You don't have to do anything. After I uninstall everything, when I type MySQL, nothing is showing up. Once again, if you don't have this, don't worry. I will now go to my dear friend Google and say, how do I download MySQL on my machine? You will click on the first link. Scroll down MySQL community downloads, scroll down MySQL installer for Windows, and I'm going to download this particular big file, 431 megabyte. So when you click on it, it will start downloading. You can say no thanks, just start my download. Okay. And it's gonna take some time. So make sure you wait till it is downloaded. So the file is downloaded here. You can just double click to start installation. Yes. Now here, see, you can select default installation, but that will require you to install Microsoft Visual Studio and all kind of components. It can get confusing for some people. Therefore, I will use custom. You will say next, and you will install the server, okay, MySQL server. So by clicking on green arrow, you can move it to the product to be installed. In the application, you will use MySQL Workbench, which is an interface where you can run MySQL queries. I don't need Visual Studio. MySQL shell can be useful. Even if you don't install it, I think it's okay. You don't need router, at least for this course. Then in the connector, you need only .NET connector, okay? And this is required if you're using BI tools such as Power BI. If you're not going to use Power BI, I think you can skip that as well. You don't need to install other connectors. And in the documentation, I will just install all the samples and the documentation. So these are the components that you're going to install. Click next. See here in my case, I had some old files which exists, but if you don't have old files, you will not see this message. Just say next, execute, and it will start installing these components one by one. After waiting for a few minutes, all the components are installed. I will just click next, next, and it is configuring the development computer, the local computer with this port. Say next, next. And in the root password, you can just say root. So root ROOT. So I'm keeping my root user, which is the main user of this MySQL installation, to be root. Next, 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 execute. Finish, next. And here you can root, right? That was the password. If you gave a different password, then give that. Check connection successful. Execute. Finish. Next. Finish. So now see, it launched something called MySQL Workbench. So here we'll be writing the SQL queries, exploring database, importing database, all kind of things. And now we are done with the installation part. To install MySQL on Mac or Linux, you can simply go to YouTube and search for MySQL install Linux or Mac, and you will find so many videos. You can follow one of those videos and install the latest version of MySQL. I am going to use 8.0.30 version of MySQL throughout this course. So you can use the same version or any version that comes later on, any latest version. Installing these softwares nowadays is pretty easy, pretty much next. And if you want to build a career in data industry, honestly, installing software is something that you need to learn. If you are facing some problem, let's say during installation, you get an error, just copy paste that in Google. You will find some answer on Stack Overflow or some other website. So I'm hoping you can install MySQL on your own on Linux or Mac. And if you still have a question, we have a Discord server. So you can find the link below this video. You can go to the Discord server and ask the question. But once again, doing things on your own and trying to figure out your problems on your own is a very nice skill to have. And installing a software is something that even a high school student can do it easily. Once MySQL is installed, you can launch MySQL Workbench by going to Start option and typing it MySQL Workbench. This is the tool that we will be using for writing our SQL queries, for making updates and so on. By default, you see this local instance, but just in case if you're not seeing this particular thing here, you can click on plus icon, type in local instance, SQL course, whatever, and just say test connection, and it will ask for a password. The username and password both are same, root. It says successfully made connection, and when you hit OK, you will see this entry. But see, since I'm seeing this already, I don't need it. So I'm just gonna delete this, and I will click here. And again, if it asks for a password, root, and just hit that save in vault option. Now, this is how this tool looks. On the left-hand side, you see these 3 entries, and these are databases that comes with the default MySQL installation. If you look at this database, it has tables related to movies, but we are going to use our own movies dataset. We will not be using this. So you can ignore all these databases, and we are going to now import our movies dataset. So how does that dataset look? Below this video, there is a download button. If you click on it, you will be able to download 2 files. First file is this movies_db.xlsx file, and the second one is .sql file. Okay, so we are going to import this .sql file into our MySQL. So I will go, let's explore all these different options. So in the server, there is an option called data import, where you can say import from self-contained file. Click on these 3 dots, go to downloads, wherever you have downloaded that file, click on this and say open. And let's look at all the options that we have. Okay, this looks good. Click on start import. That single file contains our entire movies dataset, and this green bar shows that the database is imported correctly. You can hit refresh icon and see here you see movies database. Now this database has tables, views, stored procedure, functions. So what are the tables? It has actors, financials, languages, etc. Now you must be wondering, okay, what exactly is a table? What is a database? Let me explain you using the other file that we downloaded, which is the XLSX file. So let's open that file by double clicking on it. And this is how that file looks. Now this file has multiple sheets, correct? See? And the first one is movies, and you can see it's a pretty simple database. If you are watching movies, you will immediately get an idea that, okay, there is a movie title, industry, which year it was released in, and so on. So here, if you have worked with Excel files before, Excel file can have multiple sheets, and every sheet will have a tabular data. And when I say tabular data, it means rows and columns. Okay, so see, there are these many columns: title, industry, release year. These are all called columns, and these individual entries are called rows. So our database is exactly like this. It's a tabular data structure where one table means one sheet. So movies is one table, financial is another table, actors, languages. So there are total 1, 2, 3, 4, 5 tables, right? Now watch our database. Actors, financial, languages, movies, and actors. We also have 5 tables. Now you look at our movies table and there you see these 3 icons. When you click on the third icon, it will show you the records in that table. Okay, so it ran this select query and it showed you all the records. And if you look at these records, they look exactly like this because I have imported data from this file only. And we will look into how to create the database. But in the initial few videos, we will be mainly focusing on querying the data, because as a data analyst or data scientist, most of the time, 80-90% of the time, you are mainly querying the data. You're not updating or creating tables, things like that. So we are focusing more on the query part. And here, as you see, that you have 1, 2, 3, 4, 5 tables. Okay, in the Excel file also, you had this file 5 tables. And within a table, all these entries that you have, those are called rows and these are called columns. So you can see when I run this select query, you saw different rows and these are different columns. So movies is a table, movie actor is a table, financial is a table. There are total 5 tables, and that makes up a movies DB, which is a movies database. So database is a collection of tables. A table is nothing but a tabular data, which means rows and columns. Folks, it is as simple as that. If you use Excel, you will immediately get it. I know you all are smart enough. Now, you might be seeing smaller fonts here. So if you want to increase the fonts, what you can do is edit preferences. And in that, you can go to fonts and colors. And here you can increase the font size. So SQL editor is basically this thing that you're seeing here is SQL editor. Results grid is the results that you're seeing here. Okay. And you can just increase the fonts to whatever size, 18, 20, 24, whatever. Okay. You can also do control scroll up, and that will also increase the font size. Now you already got a taste of the first query, your first query ever, which is a select query. And when you say select star from moviesdb.movies, it will return all the records. All right. In the next video, we are going to dig further into this select query. In the last video, we saw our first SQL query, which is select star from moviesdb.movies. Star here means all the columns. Let's say you are just interested in title and industry column. You can do that by typing in the name of those columns separated by comma. And when you run this, it will show you only 2 columns. When you work in industry, you will see tables which will have 30, 40 columns. So if you need only 2 columns, it is recommended you retrieve that much because that can help with the performance. The syntax here is you will write select, column names, then from, and then the name of the table. Now we are writing movies DB because we have multiple databases, movies DB, Sakila, Sys, World, etc. If you want to remove this and just write movies, what you need to do is one of the following options. You can do use movies DB. If you do that, what this use clause will do is it will tell SQL that this is my default database. So whatever table I am referring to, I mean this particular database. Now, another way of doing this, if you don't want to use this, is you can say right click and set this as a default schema, and you will see that this becomes bold, which means it will now use this particular database as my default. But I want movies DB as a default database, so you can right click and click on set as default schema, and in that case, when you do this, you can run this queries easily. You don't have to say moviesdb.movies. Now let's go back to our original query, which is select star. And you will notice that we are seeing two types of columns here. One is text column, which is title, industry, studio. The other is numerical columns, release year, IMDb, language ID, etc. Numeric means these are numbers. In this particular video, we are going to query our database using text query, which means, let's say I want to get all the movies from Bollywood industry. You can use something called where clause. So you will say where industry is equal to Bollywood in double quotes. And when you run this, it is showing you only Bollywood movies now. See, only Bollywood movies. And in the bottom output panel, it will show you the last query's result statistics. So here it says it returned 18 rows and it took this much time to fetch that data. So that is the purpose of this bottom panel that you see below the results grid, right? So to understand the anatomy of this tool, there is an SQL query editor, there is results grid, and there is this output panel. You can do the similar thing in regular Excel file by doing your regular data filter. So in Excel, if you go to data, and let's say if you type in filter, here I can set those filters, and I can say Bollywood, okay? And it will return me 18 of 39 records. See, total 18 records. And here also, if you count this, these will be total 18. Now, by the way, there is something called count. So if you want to return the count of Bollywood movies, you can say count star, and it will tell you the count. See, 18. So there is 18 Bollywood movies. How many Hollywood movies? So I'm here comparing what you do in Excel with SQL. So you're getting an idea. This is very similar. So in Excel, when I say filter by Hollywood and I see total 21 out of 39 records, I will do this here, Hollywood, and see 21. Hooray, correct? And you might have noticed that. So let's print all the columns. See, all Hollywood movies. Now you notice that here this is a case insensitive search. Means in the database my H is capital, but in my query I'm saying H small, and it still works because doesn't matter what is the case, it's gonna always work. Let's say you want to figure out how many unique industries are there in my database. For that, you can use this clause called distinct. Okay, so select distinct industry from movies. And when you run this, it will say Bollywood and Hollywood are unique industries in my database. After distinct, you need to specify the column for which you want to get unique values. The same thing you can see in Excel by the top filter. See, here the list that you're seeing is exactly the distinct query result. Now, let's say you're working in this company called IMDb. You might be aware about IMDb website, which is the movies website, okay? And this website has this advanced search option where you can search movies by their title, rating, and so on. I want to know all the Thor movies which are released so far. I can type in title Thor and I can search, and I will see all those amazing Thor movies. Imagine you are working in IMDb as a database engineer or a data analyst. And when on the website some user is making this query, from website it will make a call to a backend. That backend could be written in Java, C++, Python, Kotlin, whatever that language is. And when in backend you know that user is querying all the movies which has Thor in the title somewhere, it will make an SQL query into a database and it will retrieve all these records. See, these are all the records which SQL query can retrieve. And the SQL query will look something like this. You will say, select star from movies, all the columns, where title is like Thor. And you will say percentage. Percentage means before Thor word there could be any string, and after that there could be any string. In the title, if Thor appears somewhere in the string, give me those movies, and you will see that I get these 3 movies. Okay, and this is called a wildcard search. Now, since all movies are starting from Thor, even if you don't give this initial percentage, it's still gonna work, because this means all the movies that starts with Thor followed by any character, any number of time. Percentage means that. Now let's say you want to see all the movies for Captain America, and if you search for America like this, you won't see any movie, because usually Captain America movie starts with Captain and then America. So you can do something like this. See, now you are seeing all the Captain America movies. This is amazing, right? Like now you have been using IMDb website, and now you're getting a feel of what's going on inside, and that makes you realize how powerful SQL is. Okay, let's print the original query here again. Now in our data set, you will see that some values for studio are blank, and I want to print all those movies which doesn't have studio. This could happen because of data collection error. We have some issues in the database. This is perfectly fine. You will always see real databases having null values, data quality issues, and so on. And as a data analyst, you might want to figure out which movies have studio set to empty, and the empty string you can set it by double quote. And see, I have 3 movies for which I don't have any studios. I want to share a quick tip on how you can save these queries for your future reference. First of all, you can have multiple queries in this same SQL editor, and you can execute them one by one by highlighting them with your left mouse click. After that, if you want to save these queries for future reference, you click on the save icon. You can just say SQL course, just give some name, right? This is chapter 2, chapter 3, whatever. And you save it. And when you save it, next time, let's say I want to open it. Let's say I closed it. I closed everything. Next time when you want to open it, you can just go to MySQL Workbench, click on this icon, and go to that folder where you saved it and see queries chapter SQL course chapter 2. This was the file we saved last time. And this way you can retrieve those queries, and you can again select and execute that. You can follow this guideline throughout the course. Whatever you want to save, you can save it in .sql file, or you can create a Google Sheet document and just kind of keep your notes there. So that was a quick tutorial on how you can do text query using SQL. Throughout the course, you are going to see a lot of exercises. So folks, make sure you work on exercises, because learning SQL is like learning cooking. If you just watch 10 videos on YouTube where people are making paneer tikka masala, you're not going to learn paneer tikka masala, right? You have to take the pan, cut paneer cubes, and start trying it out. That is the only way you can learn cooking. Similarly, see, you want to build this bright future as a data analyst, data scientist, you have to practice, and you can see SQL is actually not hard, all right? Once again, I am on IMDb website, and let's say you want to see all the movies which has a rating greater than 9 or equal to 9. You can go here and search, and it will show you all the amazing movies. Greater than 9 rating means these movies must be good. How do we do exactly same thing in our MySQL database? So what we are going to do here is, again, we will write where clause, and we will say IMDb rating greater than equal to 9. This is how you specify that. And when you run this query, it will show you the 4 movies which has greater than 9 rating, including 9. If you don't do this, This means greater than 9. It will not include these two movies which has 9.0 rating, and you will see only 2 movies in the search result. You can do similar thing in an Excel file by going to data, clicking on a filter on IMDb rating, say numeric filter greater than or equal to 9, and you get this. If you just do greater than 9, you get only 2 movies, correct? So you will see a lot of similarity between these Excel operations and MySQL here. You can use the other operators as well, such as less than, this is less than equal to 9. So let's say all the movies which has less than 5 rating, these movies are something you don't want to watch. You can get it using this operator. Now let's say I want to get all the movies between 6 and 8 rating. One way I can do that is I would say any rating that is greater than 6, and so I can use this and operator. I will say, and the maximum rating is, let's say, 8. When you run this, you see all the movies between 6 and 8 rating. So you can use this AND operator, but the better way is to use between operator, where you will say IMDb rating between 6 and 8. And that will give you the same result, but this is little easier to read. This includes both 6 and 8. Now, we looked at AND operator. There is another operator called OR, and it is used in scenarios where, let's say you want to retrieve all the movies in the year 2022, 19 and 18. So how do you do that? You will say IMDb rating is equal to 2022. Oh, sorry, release year actually. Release year 2022. This shows you only 2022. But let's say you want to get more. So, and some people, the way they write SQL queries is by using this type of format. Okay. So it's up to you. How do you want to do this? But, or you can say release year is 2019, and it shows 2019 and 2022. You can also say or release year 2018. Now you can have 5 such years, distinct years, and you want to see all the movies. The better idea is to use in operator. So I will do now the exactly same thing using in operator, right? So you want to include 2022, 19 and 18. You will say where release year in, you specify all your years. Okay, so 2020, 19. And this gives you exactly same result. You can use this in operator for text queries as well. Basically, you want to, it's like select clause with where condition, and you are having couple of or conditions. So these are or, okay. So 2022 or 19 or 2018. You want to see all the movies from, let's say, Z Studios and Marvel Studios. You can do like Marvel Studios. And obviously this should be studio, appropriate column name. And the other one is, let's say, Z Studios, and you will see movies from both of these production houses. Now let's go back again to the IMDb rating, and you will notice that there is one value which is null here. Okay, this null means null. For a numeric column, null is a valid type. Null means we don't have the value available. And when you want to retrieve the records which has no IMDb rating, basically, you can say where IMDb rating is null. and see, it shows you only one record. You might have humongous database and you want to get, let's say, all the records which doesn't have IMDb rating due to whatever reason, data collection error, or maybe movies released just now, you don't have any rating yet. You can do opposite of that, where you want to retrieve all the records which have valid value, and you can use this not operator for that. You're saying, give me everything which has some value. Okay, so make sure you make a wise use of is null or is not null whenever there is a situation to use them. Now, when I print all the movies with IMDb rating, let's say I want to print IMDb rating of all the Bollywood movies. Okay, so I will say where, let's say, industry is equal to Bollywood. This is case insensitive, of course. So you see all the Bollywood movies, but now you want to order them. You want to see the highest rating movie and then the next highest. How do you do that? You can use a clause called order by, and you can order by IMDb rating. Okay, so it will order by that particular column. And you see, it started from small value and going all the way up. See, these are the rating. This is the worst rating ever, then 7.2, 7.4, ascending order. So by default, the order is ascending. If you want to go by descending order, you can specify DESC. That's a specifier that will tell you first print highest rating, the next highest, and so on. The default is ascending, and that is specified by this keyword called ASC. And let's say I want to see only first 5 highest rating movie. When I do this, it is showing me all kind of movies. I want to see only first 5. Let's say you have a business manager who is coming to you and saying, hey, Mr. Data Analyst, can you give me a report or a CSV file with top 5 movie ratings, right? Top 5 movies with the highest rating. You can use a clause called limit. Whenever you say limit, it will retrieve only those many records. Okay, see, limit just those many records. And you can use this data export option. So when you say export data movies DB by rating, movies by rating, let's say that will be the file name, and you can just maybe save it in a downloads directory. It got saved. And when you look at your download directory here, you notice this new CSV file, movies by rating. And this has, see, all the movies with the highest rating, the top 5. This is very common use case in the industry where a business manager comes to you, asks for a report. You run some query, export it to CSV file, then you compose an email, say, hello, Mr. Business Manager, here is the report that you were looking for. I ran the same query, but this time for Hollywood movies. And let's say I want to start with the second movie. I don't want to see the first movie. There's this thing called offset, and the offset starts with 0 index. So this is 0 index, this is 1. So let's say you want to see all the movies starting from second highest rating movie till next 5 movies. You can do that by saying limit 5 and offset 1, because see, this is index 0, this is index 1. And when you do that, see, Godfather, these 2 movies have 9.0 rating, so the order might be swapped, but don't worry about it. You can do, let's say you want to start with Inception, and that will be offset 2, 3, 4, right? So 4. So there will be times where you have to use limit along with offset. That's all we have for this session. Make sure you work on exercises, because the secret of getting things done is to act. Just by watching this video only, you're not going to learn anything. You have to practice, and for that reason, we have given you a lot of exercises along with the solutions. In the next video, we will be talking about summary analytics related queries. In one of the previous videos, we looked at count star function, which can give you the total record count in a given table or for a given condition. Count star is an inbuilt SQL function. Now you may wonder what exactly is a function. Let me explain you by giving the example of a computer. On the computer, I have various keys like the power key, the LED key, USB, I can plug USB. So these are inbuilt features of a computer. I can turn on or turn off monitor. All right, so these are inbuilt features of a computer, and these features are turning on computer, turning off computer, turning on LED, and so on. Similarly, in SQL, there are various inbuilt features. Count star is one of them, and the way you call this inbuilt feature, also known as function, is you will write the name of the function, then you will have bracket. Inside the brackets, here we have star. So this is called an argument in the function. In the future, we will see a lot of functions where we will have multiple arguments. All right. I hope the understanding is clear. Let's move on in our video now. Now we're going to look into more of these type of functions, which allows you to do basic analytics. See, you are trying to prepare for a data analyst or data scientist career. You will be using all these functions very often when you get a job. The first one I want to cover is max. Let's say I want to get the maximum IMDb rating for Bollywood movies. By running this query, it will show me the max. Similarly, there is a mean function which will show you the minimum rating among all the Bollywood movies. Let's say Marvel Studios is releasing all these awesome movies, and you want to know the average rating of the Marvel movies. You can use this function called AVG. And as you see this, when you type, the autocomplete will give you suggestions. Okay, and you can use those suggestions. And here I am interested in studio equal to Marvel Studios, correct? That's what it is. And this shows me the average rating of the Marvel Studios. Now, when I printed average, it's showing me too many decimal points. And if I want to restrict it to only 2 decimal points, I can use this function round. I can say round it to 2 decimal points. Okay. And after dot, now you will see only 2 decimal points. One thing you're noticing is this header, column header, is getting very bigger. And in SQL, you can define your custom column header by saying this as AVG. For example, AVG rating, something like this. And see, it will print that. Now, this is useful in scenarios such as, let's say you want to print min, max, and average rating, everything for Marvel Studios. The way you do that is you will say select min IMDb rating as min rating, and then you do the same thing for max. So I will say max IMDb rating as max rating, and then I think this is average. And when you run it, see, it gives you all these ratings. Now I'm going back to my original query where I printed number of movies in Bollywood. I can print it like this. And if I want to print the number of movies for Hollywood, I can print it like that. But what if I want to print both the numbers at the same time? I can have, say, 5 different industries in my movies table, and I want to have industry name and the count, industry name and the count, something like this. See, what if I have Hollywood? Let's say Hollywood has 18 movies and Bollywood has 10 movies, and Tollywood has, there are all kind of woods, has, let's say, 5 movies. How do I do that? For this, you have to use something called group by. And the way group by works is you will say select industry, because industry is the name of the column, okay, and count star from movies. And by the way, sometimes I'm using small case, uppercase. Some people use uppercase for the keywords, which are special SQL keywords such as select, from, where, etc. Both of that works, okay? Small case, uppercase works. It just, sometimes it's useful to see the keywords in uppercase. And here I will say group by. So the group by clause will allow you to specify on what criteria you're grouping things. So here I am grouping things based on industry. And when I run this, see, Bollywood 18, Hollywood 21. Let's say you want to group things by studio. And studio, again, this has to be the column name, okay? Here, let's say studio. I need to specify the studio in my column. Only then it will work. So let's say Marvel Studio has 8. Now, as you can see here, the count is in a random order. But let's say you want to sort the result based on this count. What you can do is you can say count star as CNT, something like that, some short name. And you will say order by CNT, descending order. And then you will see the studio which has the maximum number of movies. Here it is Marvel Studios. There was one studio which was blank and it has 3. So that's probably a data error. Now let's say you want to print the industry, the movie count, and the average rating in that industry. You can do that. So previously, if you remember, we had this particular query where we were printing industry and the count. Now the additional thing you want to print is the average rating. So what you'll do is you'll say this is the count and average IMDb rating, let's say, as average rating. So see, the average rating for all Bollywood movies is 7.6 and it is 8.16. If you want to round this, you can round it 2 decimal point, or let's say 1 decimal point. And now I want to, let's say, print average rating by studio. You can do that. Again, you will do studio here and you will group things by studio, and you want to order things by average rating, right? So you will say order by average rating, descending order, meaning the display the highest value first. Let's see how this looks. Here you will supply studio because you are just selecting the studio, so you can just say studio and average rating as average rating. Okay, so let's see what this prints. See, it is printing the average rating of all these different studios. Now here I am saying universal pictures, and universal pictures like two are repeated, and this is because of a data error. So if you see, if you just copy this field, okay, you can right click and copy the field, you will see this. And if you just copy this field, right click on this, see, you see this extra space. So many times in databases you can have these kind of issues, and we need to fix those problems by updating the records. Anyways, but you are seeing how the average rating is being printed here. And let's say you're seeing this studio which is blank, and really that's a data error. So you want to just skip that part. The way you can do that is using our where clause. So you can say where studio not equal to this, and in that case that particular result will be cleared out. Now friends, don't try to memorize all these functions. There are so many functions. What you need to learn is the art of Googling. Googling is the skill that will help you rise in your career. So let's say I want to know all the SQL functions. I can say SQL inbuilt functions. And you will see so many good websites such as W3 Schools, for example. Here they're talking about SQL server function, but let's say MySQL inbuilt functions. And see, on this website, you will see all this list of functions, string functions, and then numeric function. We looked at, say, min, max, all of that, right? So here you can just practice on this website. You can also go to MySQL's official documentation where they have listed all the operators and all the functions. So for example, we looked at AVG function. Here it says returns the average value, and you can go in, read the documentation and try out some of the queries that they have specified here. So once again, don't try to learn all these SQL functions or memorize it. I don't remember most of the SQL functions. Whenever I need to use them, I will just do Google. Okay. For example, I want to find outliers in my data set and I want to use standard deviation. I will say MySQL standard deviation function, and immediately it says stddev. All right. So make sure you focus on this art of searching or art of Googling. That is the key for the success. Let's say you want to print all the years where more than 2 movies were released. How would you do that? This is clearly a group by operation because you are grouping your rows based on the release year and you're getting a count. So let's write the query. We'll say select release year first. So you want to print a release year and the count of movies. So you would say count star from movies and group by release year. Okay. And when you execute this, you get the count. Pretty straightforward. You can also sort this by saying that, okay, I want to order by count, and I will just say count star as movies count so that I can refer it easily in my order by clause and descending order. When I run that, pretty straightforward. So this 4 years were the years where my movie count was more than 2, but this is showing you all the results. Let's say you want to filter all the results, right? So I want to say where my movies count is greater than 2. So you can probably use where, correct? You will say where movies count is greater than 2. But when you will run this query, it's not going to work. It will say unknown column movies count in where clause. And the reason this is happening is the way SQL will execute all these operations is it will first execute from operation. Okay, so it will say from movies, I want to select bunch of records. Then it will execute where, then it will execute group by. So now movies count is not available until group by is executed. But where is executed before group by. So when where is executed, it doesn't know what is movies count. That is the reason it doesn't work. Luckily, there is something very similar to where which gets executed after group by, and it is called having. Okay, and in the end you execute order by. So let me just move this after group by, and instead of where, I will just say having. It is very straightforward, and see, it's gonna work now. So you need to remember this order. It's first from, then where, then group by, having, and order by. Having is used mainly with group by operations. Okay, so when you go work in the industry, remember this thing. Having is mainly used with group by, but it can be used without group by too. But the main use case is with group by. And another thing that is different with having and where is that when you have where, see, let's say I want to get all the movies whose IMDb rating is greater than 6. In the where clause, if I'm using a column, that column doesn't have to be in my select statement. So let's execute this. So it still works, but in having whatever column you are referring to has to be there in the select. So if I just say, okay, IMDb rating greater than 2, whatever, that's not going to work because IMDb rating is not available inside the select clause. Most of the time, you will find that the column that you're using in having clause will be an aggregated column. For example, here movies count is some kind of aggregation, correct? Or a derived column. So these are the use cases that you will see in the industry. So far we looked into movies table. Today we are going to move to a different table called actors, and we'll discuss calculated columns or derived columns. When you look at this data, you have actor name and birth here. And for your analytical purpose, you may want to get an age for each of these actors. Let's say you want to do analytics such as what is an average age of an actor in Bollywood or Hollywood, who is the youngest actor in Hollywood, etc. Having age will be very helpful in that case. And the way you derive the age is you will get a current year and then subtract birth year from that. Now, to get current year in Excel, there has to be some formula. And I don't know what that formula is. So I can go and ask my dear friend Google. So you can just say Excel get current year. And you will find this formula and you can just use that. Okay. See, I use that formula, and when you do this, you get the current year. And then from that current year, you can subtract the birth year. Okay. Okay, I think there was some issue. So let me do this again. So I will say, this is my current year. I will double click, type in that year minus birth year, and that gives me the current, the age of that actor. And you can just click on this and see, you see the age of each of these actors. Can we do something similar in MySQL? So I will now replace my Google search with MySQL get current year. See, what you type in Google is a very important skill. This is the skill that can give you superpowers. So do not underestimate that. Good programmers or good data scientists and analysts, they don't remember the syntax. They know the art of how to search for the answers. And I get this article, let's say. And see, there is a function called year, which can take date as an input and it will give you the year. For example, in this case, it will return 2017. But I don't have a date. I want to give a current date. How do you get current date? Well, this is the way. When you use a function called CURDate, it will give you current date and then you can take year portion from it. So I'm going to copy this into MySQL. So I will say select current date and it gives you the current date. And when you wrap it around year, when you call it from year function, it gives you current year. Okay. Now, all you need to do is, once you confirm that this returns the current year, you can say star from moviesdb.actors. We don't need to type moviesdb because it's a default database. This will return all the columns. And in addition to that, you want, let's say this as a new column. So now you got current date and you can just say minus birth year as age. You can say as age and then it will print that as an age. Here you can give any column name. This is up to you. But see, getting the age was as easy as just typing a formula and using that in a select statement. Now, let's go to a different table, and that table is financials. We are going to use some more calculated columns for financial tables. When you look at this table, let me show you this table in the Excel file. And what this table has is the movie ID. For example, 101 is KGF chapter 2. And in the future chapters, we'll look into how you can join two different tables using left join, right join, etc. But for now, using ID, you can figure out which movie is that, right? 102 is Doctor Strange. And for 102, which is Doctor Strange, they made $954 million in box office as of the date that this data was captured. And their budget for making movie was 200. Now let's say you want to calculate the profit columns. How do you do that? Well, it's very simple, right? It is profit is equal to this minus budget. And we will be able to do same thing using the formula in MySQL as well. So what we'll say is revenue minus budget as profit. So star means all the columns. If you want to print selected columns, you can specify their name separated by comma. But see, this worked fine. Now let's say you want to print the revenue of all the movies into a single currency, because right now these numbers that you're seeing, they are having this dimension of currency and unit. So you can't compare these two numbers. You can't say, okay, this movie made more profit than this, because this is in USD, that too in millions, whereas this is in billions of INR. Okay. So if you want to do apples to apple conversion, you have to convert everything into a single currency and everything into single unit. Okay, but that's a separate discussion. For now, let's say your purpose is to convert everything into INR, so that the currency that you see here is the INR currency. And how can you do that? Well, USD to INR currency conversion ratio right now is 77. It is changing every day. If you're working in any organization and if you're doing currency conversion, you will use the live spot rate, the currency conversion rate, as of the date when this data was captured. But since this is a tutorial, I want to keep things simple. We'll just assume that USD to INR conversion ratio is, let's say, 77. So if you want to convert 954 millions into Indian rupees, you will say 954 into 77. Simple. Okay. So how do I have a new column called, let's say, revenue INR? Okay. So I want to have a new column called revenue INR, and every revenue is in INR. We will use something called if condition. So the if condition, the way it works is this. You will use if condition and you will say if currency is equal to USD, then take revenue and multiply it by 77. And if it is not USD, just print revenue. Okay. And let me run this. So what happened is, if the currency is INR, then it is keeping it same, 12.5, 12.5. But if it is USD, then it is multiplying this number with 77. And you can verify that by using some tool called calculator. So let's say 954.8, see 73519. Okay. So the way this if condition works is, in if, the first thing you have is a condition. The second thing you have is, what do you want to do if the condition is true? And the third thing is, what do you want to do if the condition is false? It is as easy as that. All right. Now let's print all the revenue numbers into millions currency. Ideally, if you want to, let's say, find out which movie made the maximum money on box office across the board, you know, all the Bollywood, Hollywood movies, and you want to compare, okay, which movie made the most money. In that case, you have to convert revenue into single currency and then into single unit. And that will make our query a little complicated. And we are in a stage of the course where I don't want to make things too complicated. Therefore, since you learned currency conversion, I will now do unit conversion. Okay, I will not do currency conversion, just the unit conversion. So for unit conversion, what you have to do is, let's first find out how many units we have. So you can say select distinct unit from financials. Okay. Do you have any memory of what this will return? It will return the number of unique values that this column has. So billions, millions, and thousands. We have 3 values. Now, millions is a very popular currency. So what I'll do is I will convert everything into a million. So I will have some condition here and I will print revenue in millions because that's very popular. How do you convert billions into millions? So to convert billions into millions, you have to, whatever number you have, let's say you have 12 billion, okay? What will be the millions? It will be 12,000, which means you are multiplying 12 with 1,000. So the condition is, if the value is in billions, you multiply your revenue with 1,000. But if it is thousands, let's say you have these many thousands, you divide that by these many thousands, okay? These many thousands meaning this is the actual number. So these many thousands is actually 4.567 million, okay? So the formula that you will use here is revenue divided by 1,000. Okay, this is like a simple math. Okay, so if condition is useful when you have binary condition. Previously we had if USD, then do this, otherwise do that. But here we have more than 2 conditions to check. If billions, then do this. If thousands, then do this. And if the unit is in millions, then just keep things as is. Okay, so how do you express that? You can do this using something called a case statement. Okay, now how does case statement work? You will say MySQL case statement. You are using your most powerful weapon, folks, Google search. And the way case statement works is you will say case and you will specify when some condition, then this, when some other condition, then this, else, then this. Okay, so let's do this. So you'll say case and. So whatever you get from case, that output will be stored in revenue million. What is your case? Okay, my case is when currency is, let's say, thousands. When currency is 1,000, what do you want to do? Then you want to divide revenue by 1,000, correct? And then when currency is billions, then you want to multiply revenue by 1,000. Okay, let's run this. You can select this. Actually, comma is not needed. Okay, there is some problem. So not currency, actually I have to check unit. Okay, I mixed up 2 things here. Okay, so see, when it was 12.5, it converted into 12,500, which is fine. But I'm seeing blank here because for millions I did not do anything. So you have to specify your default case, which is else. If the unit is everything else, or you can also say when unit is equal to millions, that is probably the right way. When you say unit is equal to millions, then this is probably the right way. But now that we already know that we don't have any more units, you can also do this else. Both are same. Okay, and now all the numbers you see are in millions of either dollar or INR. Okay, as I said, the right way is to convert now this number into USD or INR, but maybe you can do that. It will make your query look a little complicated. All right, so I hope you learned few new things here. I'll see you in the next video, and make sure you work on the exercises. In our movies database, we had multiple tables, and in this lecture, I'm going to discuss why do we need multiple tables in first place. I will be using a different data set of grocery store customer transactions. So when you go to a grocery store and buy things, they have a POS system, and in that system, you could have transactions that might look something like this. So there is a transaction date, which item you bought, the item category, price per kg, order weight, name of the customer, customer email, customer address, and so on. Now you can have all the data in one place, just like how I'm showing you here on this screen, where every single information that is needed for a given transaction is present in one record. Okay, so you have price, you have item, you have customer, you have everything. And this works fine, but this has some disadvantages. Number one is information is repeated. See, Peter Pandey, his information is repeated. Let's say Peter Pandey has 1,000 records. You're repeating that information in the database. So that's a disadvantage number one, data redundancy. Second disadvantage is tomorrow, let's say potato prices go up and now you want to change from 60 to 80. And if you have other records, you have to update all of them, right? For example, here, let me take example of broccoli. Broccoli price change from 120 to, let's say, 150 tomorrow. Okay. I mean, you cannot change it per transaction, but I'm just saying in the future transaction, you need to have that different price. You need to have price associated with that item somewhere. And the third disadvantage is the data is not organized properly. So let's look at how it will look if the data is organized into multiple tables. So I will first take customer information and put it in a customer table. So there's customer name, email, customer address, and we will give a unique ID for that record. So this is the unique ID for that customer. We will do the similar thing for items too. Item name, item category, and price. Okay, and we might have year also. I'm just giving a simple example. Usually in databases, they will have a year or date because the prices are changing constantly. And once we have this, our sales table will look very neat and clean. See, it will have item ID, customer ID, and order weight. So what is this record? Okay, let's look at 21 item. So 21 item ID is white potato, vegetables, and 60. Okay, so you can replace that 21 with this. This is your item information or product information. Okay, so that's item number 21. And 401 is Peter Pandey. Okay, so 401 is Peter Pandey. So you can put 401 here. So see, now I'm just putting this information for a reference, but you saved a lot of space in your database. Also, the data organization is much better. When you want to check prices for items, you just go to items table and that's it. You want to change, let's say a customer comes and say there, oh, I changed my email ID. All right, fine, go to customer table and this table will have very less records. So you can just change email ID here. But if this customer information is in main sales table, which can have thousands of records, changing email ID everywhere might be a painful process. When we talk about our movies database, exactly same principles applied. Let's say I want to have all the information in one table. One of the information I have is actors. For example, in movie KGF, there were two actors, Yash and Sanjay Dutt. I want to put that information here. How do I put it? Okay, I can do like Yash, and his birth here, right? Like actor birth year. Okay, so let's say his birth year is 1986. I can do this, but where do I put the second actor? Do I have actor 1 and then actor 2? Maybe do I have information like that? But that's not good because I can have more actors, right? Like if I put Sanjay Dutt like this, see, whatever. So then information organization becomes difficult if everything is in one table. For that reason, we have this concept of multiple tables. And especially for actors, what we do is actor to movies relations is many to many, which means one movie can have multiple actors and one actor can participate in multiple movies. Therefore, we created a separate table called movie actor. This is like a mapping. Okay, 101 is KGF 2, 50 is Yash, 101 again is KGF 2, 51 is Sanjay Dutt. So this table will allow you to do the mapping. And in the future videos, we will see things like, okay, print me all the movies along with their actor names. And in order to do that, we will be using something called joins. Let's say a business manager comes to you and asks you to generate a report where there is a movie title and there is budget, revenue, unit, etc. columns. Now this requires joining two tables. We have movies table which has movies titles. We have financial table which has financial details. And the common link which joins these two is movie ID. For example, movie ID 101 here, it's movie ID 101 which is KGF 2. So using this movie ID, we are going to join these two tables and generate a report. And we will look into different types of join. So let's get started. The first join we are writing is called inner join. And the way you do that is first you will specify which columns you want. So I want movie ID, title, all these columns. And to join to a different table, you will say join financials on using which column you are joining. Well, you are joining using movies.movie ID is equal to financials.movie ID. This is how you specify the common column. Okay, so you say on and then this column is equal to the right table dot column. When you run this, see, I'm getting an error here at the bottom. If you see column movie ID in the fill list is ambiguous. What this means is, see, now since you're joining two tables, these columns could be coming from any table. Now revenue, currency, etc. It did not give error for those columns because those columns are not ambiguous. A revenue column is available only in financial table. It is not available in this table. So SQL didn't have issues figuring out which column you're talking about. But movie ID column is available in both the tables. And when you say movie ID here, it doesn't know which column you're talking about. So what you have to do is you have to say movies.movie ID. And now you'll see a beautiful report of movie title and budget, etc., which you can click on this export and you can export it as a CSV and send it to your business manager. Now, one common practice that people use when they are using joins especially is to make the query shorter, they use the table abbreviation. And the way you can do that is after movie space M space F. And once you do that, now you don't need to write the whole table name here. See, I can just say M here and I can just say F here. Similarly here, I can just say M. Okay. And that makes your query shorter. The join that we perform here by default is a inner join. So MySQL by default, if you don't specify any keyword and it just says join, it is an inner join. Now, what is an inner join? So I will take an example here. So let me show you some presentation. So in this presentation, I have given few records, not all. Let's say you have these two tables, okay? And these movies, Sholay and Inception, they are not available in financial table. So they have some movie IDs, but those movie IDs are not available in financial table. Similarly, financial table has some records, some movie ID, let's say 406, 412. These are not available in our movie table. Okay. And you will actually see this is the case. Let's look at movies table here. Okay. Here we have this movie, Inception 112. If you look at financial table, you don't find a record called 112 because of data collection error or some problem. That record is not available, and this can happen in real life databases. Similarly, the other record, Sholay 106, is not available here. See, you look at the entire table, that record is not available. So there are some records in movies table which are not available in financials. There are some records in financial tables, such as last two records, 406, 412. These two records represent movie IDs which are not available in movies table. See, movies don't have any 400 type movie ID records. So when you now do inner join, what happens is it will only take into account the common records. It's like if you have a Venn diagram, it's an intersection. Okay. And that's exactly what happened when we ran this query. When we did inner join, you would not see any Sholay or Inception. Just look at this whole list. You don't see Sholay or Inception because it is available in left table but not right table. Similarly, in the financial table, which is my right table, I had 406, 401, 412, but I didn't see that. See, check all this movie ID. Those are not available. Okay. What if I want to print all the movie titles? I want to see Sholay and Inception, even if it doesn't have budget and revenue numbers. If you want to do that, you will do something called left join. Left means, see, when you say from something, that becomes your left table. And the second one, which is financial, it becomes your right table. And when you run this, you will notice these, see, there is an Inception, but it doesn't have budget, revenue, etc. Similarly, there is a record for Sholay. It doesn't have budget, revenue, etc. And it will show null. Okay. So pictorial representation of this will be like this. It's like a left. All the records from left table, including the common records. You might have guessed what will happen when you do a right join. In right join, you will see all the records on the right hand side table, which is our financial table, but Sholay and Inception will not be visible. So let's just try that out. When you do right join here and run the query, see these two. So you got 406 and the other one, but you didn't get a title. Now you'll be wondering why it's not showing movie ID. You have any guess? Okay, I think you figured it out, because here we are saying m.movie ID. I want to get movie ID from movies table. If you want to display the movie ID, if you just change this to F during your right join and run it, you will see those IDs, see 406 and 412. And the final join that we want to cover today is full join, where you get all the records. Okay, so the picture gives you a complete idea on what this is about. And the way you do that in MySQL is there is nothing like outer join. See, if you do outer join, it says outer is not valid at this position. And by the way, this is the syntax for MySQL. If you're using Oracle or SQL Server, the syntax might be different. SQL is a standard language that we use for different databases, but these different databases has a slight tweak in terms of syntax. So you need to keep that in mind. So what do we do now? All right. When we did this, we got, so when we did the left join, right? So left join I think it makes sense you do m.movieid. You got this. When you did right join, okay, so let me just put these things into this line. And now when you do the same thing, but with right join, what happens? So for right join, I will use F because I want to display those movie IDs. And I want to do right join here. Okay. And see, this is right join. This one is left join. In the left join, you see certain records which are available on left, but the budget revenue is not available. In the right join, you see record which has financial details available, but not the movie title available, right? Now, let's call union on these two. So you had this to query. In between the query, when you write this keyword called union, if you have studied set theory, union is just a union of those two rows, okay? When you use union keyword, you have to make sure that these number of columns and their column names are same. If not, then it will give you an error, okay? So let's run this. And now you are seeing records such as Sholay, which is available on the left-hand side, Sholay and Inception. But you see records, these records as well, okay? Apparently, there are like 3 records in the right-hand side table. I said 2, but there is third one, which is 114. So this way, you are getting all the records. And this is how in MySQL, you can perform a full join. You should take a screenshot of this picture because it will be very helpful. It just summarizes all kind of joins that we have seen so far. Now I want to mention one more thing, which is these 3 joins, left, right, and full joins, are also called outer joins. So whatever is not the inner join, it is also known as outer join, which is a common term for this left, right, and full join. So you can say left outer join or right outer join or full outer join as well. And the MySQL syntax supports the keyword. So you can say right outer join and that will give you the same result. You see? Same way if you have left versus left outer join, that gives you the same result. But just to save some space, we don't use that outer. When you say left join, it is implicitly assume that you are talking about left outer join. Now, one last thing I want to mention before we end this lecture is something called a using clause. So here, most of the time you'll be using on because in many cases, this column name could be different. Let's say it is MID. So when you use on, you can explicitly specify the exit column names from both the tables. But in our case, both the tables have common column name movie underscore ID. So you can use something called using movie ID. And the reason you specify bracket is you can actually join based on 2 columns also. Okay. So it's not like you have to just specify 1 column using which you can join. You can sometimes join 2 tables based on 2 columns. So here you can specify whatever is the second column. But anyways, in our case, it's just 1 column. And when you do that, now you don't need to specify this M because it will figure that out in a smart way. So let's see what happens. So I have a right join. And previously, remember when I was doing m.movieid, I was not seeing the movie ID for both of this. But now I'm seeing it because it is smart enough to figure out from where to take movie ID. Similar thing will happen when you do left join. When you do left join, and let's say Sole, right? See, it figured out the movie ID. So this is a convenient syntax. You have to write less code, but this requires that the column you're joining on has a common name, which is movie ID. In real life databases, you will see that you're joining 2 tables, but the actual column names are different. In that case, you don't have any other way but to specify the exit column name using on. Now, I mentioned this previously before also, that you can join two tables using multiple columns also. All right. So let me just go back to my previous query. And here I was joining based on one column. But if you have another column, let's say another column, you can do join based on another column also, like this. Okay. You can ask your dear friend Google also. See, in Google, I typed in MySQL join on multiple columns, and immediately it will show you a page with the syntax. See, on this and the other date. And we are going to look at more complicated joins in the future videos, but this is something that you need to remember. That's all I had for this lecture. And once again, learning SQL is like learning swimming. If you just watch 2 hours of swimming videos on YouTube, you're not going to learn it. You have to jump in the pool and get yourself wet. So I guess you're getting what I'm trying to say here. Make sure you work on the exercises.